In this video, I'm going to be doing something very astonishing. I'm going to be explaining how you can actually create a model that can predict neglected tropical disease in the case of lymphatic filariasis. Now, for this particular project, I'm going to be working the Jupyter notebook and also some elements of code around Python. So it means that if you're watching this video, I expect that you're already familiar with at least some of the basics and fundamentals of programming, particularly in Python. Now, the link to the code that I'm going to be executing in this course is going to be dropped on my Git repository. So you're definitely going to find that on the description of this video. So let us get started. And I actually enjoin you to enjoy every piece of this exercise and particularly this project that we're going to be working on right now. So the first thing I'm going to do right now is I'm going to actually create a folder. That's the first I'm going to do. So I'm going to call this folder neglected. Now, I would expect that you have VS Code or you have got Jupyter installed on your system. That's we've got the Jupyter notebook or any other particular package that's going to really make it very essential for you to write this code. So now the next thing I'm going to do right now is I'm going to open VS Code. So right now I'm just going to close this. Now I'm going to go to File. I'm going to go to Open Folder. I'm sure you've done that. Then I'm going to go to my desktop. I already got a couple of machine learning projects here, and this is it. So I'm going to click on that. I'm going to select that folder, and automatically it's definitely going to open. And the first thing I'm going to do right now is I'm going to create a file. So I'm going to call this, we can call it ntd.i, stands for interactive Python PY NB notebook. So I'm going to hit enter. So automatically it's going to bring out this window phase where I can actually run my code. So I'm not really going to be wasting so much time on the setup. If you want to know how to set it up, I'm actually going to make a video and put it down in the description. So we're going to go straight into coding. Now, I'm just going to select my kernel. So I'm going to click on Python. So I'm going to click on the Python environment. I think that's it. So congratulations, we are ready to write our code. Now, just like I said, we are going to be creating a machine learning model. So I'm just going to write down a markdown of what we're going to be doing. And I said, so to create the markdown, so I'm going to use the pound sign. So we want to create a model. So I'm going to use model that can predict the risk of developing lymphatic. So I'm going to say lymphatic. If I spell that correctly, filariasis. Okay, so yeah, that's it. So I'm going to hit Shift Enter. So that's what we want to create in this video. So lymphatic filariasis is a neglected tropical disease. So we're just going to keep that like that. So now the first thing I'm going to do now is, remember, I'm going to be working with a synthetic data set. So what do I mean by synthetic data set is that I'm going to be the one to generate the data set, train it, and also use it to make predictions for this particular video. And now the first thing I'm going to import NumPy as NP. So NumPy is it stands for numerical Python. Okay, so it's used for essentially all the calculations, generating some of the data sets and all of that. We're going to use NumPy for that. So I'm actually going to import pandas, if I can spell that correctly, as PD. So what NP and PD means is an alias that we use in saving this particular package. So it means that instead of us to be typing NumPy pandas everywhere, we can actually use the short form alias to save it. So the next I'm going to import is pickle. So this is the model package I'm going to use in saving my model and also loading the model. Then from sklearn.model selection, I'm going to import train test split. So we're going to use this particular package to split our data set, and I'm also going to go into from sklearn.linear model. I'm going to import logistic regression. Okay, this is the model we're going to be using for this particular training. And also I'm also going to import, now for me to check the accuracy, I'm going to import from sklearn. I'll import from the metrics. I'll I'm trying to spell that correctly. I'm going to import accuracy score. Okay, so I think with all this we are good to go. Now if I wanted to use the decision tree classifier as my model to predict, I can actually say from sklearn, probably say sklearn dot tree import decision tree classifier. Okay, but in this case I'm not really going to be working with that. We're going to be working with the logistic regression to predict our model. Now the next thing we're going to actually do right now is we're going to start building our data sets. Okay, so what I'm going to do right now is I'm going to say np.random, if I spell that correctly, .seed. So I'm going to assign any number. Then I'm going to be working with a size of 400 data. So what this means is that what we're trying to say is that each time, because it's a randomly generated data set, it means that each time we hit this particular, or we hit enter, or we try to generate this data set again, it's going to give us that same particular set of data, right? So it's not like it's going to be giving us, if you don't put this there, each time you hit enter or you try to run this model again, it will give you another set of data, right? But keeping it with a random seed means that it is going to be what? Reproducible. So if you're coming from a research background, systematic review, whenever we say something is reproducible, it means that there is a clear guideline that has actually been given. So, but I don't really want to go into that. So the next thing we're going to do right now is we're going to actually define our variables. So we have for age. Okay, so we're going to say np dot. So from the numpy module, so np.random dot randint. Okay, so we're going to say the age range is going to be from age 5 to 71. So that's 70, and the size is going to be n. Okay, so that's the size of our data sets. Okay, so now next one we're going to see. So we're going to say the next parameter that we might need is the sex. So we say the n.random.choice. So call that method. So pass this argument inside of that. We're going to have male and female. Okay, so and the size is going to be equals to n. Okay, then the next part is going to be, so we're going to actually look at something like the swelling. We can say leg swelling score. So I'm just going to put that as np.random.randint. All right, so it's going to be from 0 to 100, and the size is n. And the next one we might have is latrine access. That's access to toilet. We can actually check out that. Say latrine access is going to be equal to np.random.choice. So we use the choice method because it's going to be either present or then it's going to be absent. Okay, so that's actually access to latrine by the patients. Then what else are we definitely going to want to know? We might actually say house, probably income status, and we can actually put this. Probably this might be a very massive predictor. So we'll say np.random, so called numpy, and we can use the choice method again, and then we'll pass. We can say, we can actually group it in 3 categories. We can say high income, and we can say here, we can say probably, or if I got that correct, medium, and then we can say low. Okay, I think I got that correct. Now, one of the things we need to understand now is that how about we want to actually add another variable? Probably want to say if they are infected. Probably if they are infected, it means that you have a score. Let's say for somebody to be infected, it means that the leg swelling score is greater than or equals to 50, right? So this is what we use in measuring the leg swelling, particularly of that condition, and also it can actually imply that, and also probably they have latrine, they don't have latrine access. right? So more like is absent. So now what we're going to do now is that there is also a method, NumPy method, that we can use in creating this particular to assign people to this particular group to have it in our data. So what we can do now, we can say infected is equals to, we can say np.where. We use the where method to now say, what we can say here now is that if the let's say the leg swelling, also I can also add the age here as well. You can see that if the age is I think probably greater than or equal to 40. Okay, so whenever the leg swelling score is, let's just start with the age probably. So if the age is greater than or equal to 40, right? And so we're going to do the and. So this and if you're coming from C or C++, you see that NumPy is built on top of C and C++. So it means that this is the operator for the and operator, right? And you can say age is greater than or equal to 40, and for you to satisfy that particular variable of being infected, so it means that age has to be greater than 40, and then the leg swelling score is probably, we can actually say it's greater than or equal to 50, and also we can say latrine access is equal to absent, right? So that means the person is infected. So we can actually drop that by saying, okay, so we're gonna assign 1 and 0. Okay, so you can run that works perfectly. So what this means is that if you're infected, it means that you're likely above 40 years old and you have a leg swelling score that is greater than or equal to 50, and you don't have latrine access. So this is more like a condition of individuals that are infected. I hope that makes some sense. Now what the next one we're going to do now is we're going to load the data frame. Okay, so we can actually say df is equals to pd. So we call the pandas method. So say pd dot data frame. So we call this constructor and we pass in a dictionary. So inside this dictionary we can now say for age it's going to be age, right? That's based on the variables that we've generated here. And then we can actually say for sex is going to be sex, right? And then for leg swelling, okay, so I'm just going to say dot. Okay, so that's going to be leg, if I can spell that correctly. And just to be sure, I can actually say the next one is latrine access. Okay, so we can say latrine access, and the next one is income status. So we can actually say is income status, and the last one is infected. We can also say infected. Now, in order to check out this, we can actually do df.info. And now what this method does is that it basically shows us everything about our data frame, right? So we have it shows us the columns. These are the columns that we have: age, sex, leg swelling score, latrine access, income status. We have infected, and for age is an integer, sex is an object, so more like look at it as a string. We've got integer, leg swelling score, we've got latrine access objects, income status object, and infected object. Okay, now we can also use another method we call the describe method. And now what this is going to do now is going to actually basically describe all the columns that are integers, right? So we get the count, try to know the count, that's data numbers. And basically what we use all this info and describe to do is that we want to actually check the data to be sure that it's clean and clear. So we've got the mean. So this is the mean across all the age groups. We've got the standard deviation, we've got the minimum value, and the 25% percentile, 50, 75, and the maximum value that is inside of there. So same thing also applies to this. Now, but I think we might want to see what the data frame looks like. I can actually press df, and when I press df, it's definitely going to pop up the data frame. So we've got age column of the patients, we've got the sex of the patients, we've got male, female, and all of that, and we've got left swelling score that is rated on from 0 to 100. We've got the latrine access, income status. Several of them happens to be high, infected. Now, if we want to actually just check the head of this particular data frame, we can actually put df.head, and so we can actually choose 5, and it's just going to give us the head. Now, if we actually want to check the last, we're going to do df.tail. It's going to give us the last 5 digits. Now, if you want to check the first 50, you can actually press that, and definitely it's still going to give you that, but I'm not going to run that. Now, if I don't want to have this particular index here, what I can actually do is print I can actually do df.toString. Okay, so I can use toString. I'm going to pass this argument, so index first, and when I run that, automatically it gives me the age, sex column without having that index. And I think I just want to shorten this a bit. I can actually put .head and put maybe 10 dot, run that. That's clear. So we have this. Okay. All right, so we're actually going to continue more of the foundations. I'm going to talk about it in the next video, particularly if you're coming from a non-programming background. Okay, so all right, so for the sake of this video, we're going to actually continue to go ahead in determining how we're essentially going to create our model. Now, the next thing we're going to do right now is, since we already have our data frame, it's going to be very important for us to, now one of the things I want you to understand is that in machine learning works with numbers. Okay, but if you look at our data frame now, for example, df.head 5, now you see that we have some sort of what we call categorical variables, and also we've got another categorical variables here, and we've got categorical variables here. So what this means is that we need to make our way with these categorical variables and encode them into what we call numerical integers, so that that's what the machine understands. Machine understands numbers. So basically everything we're going to be working with is going to be numbers. So what we are going to do right now, remember, we are trying to predict the risk. That's the risk of developing lymphatic filariasis. Okay, so before we actually encode or convert some of these parameters into numbers, we will need to create the risk column, right? So let me repeat myself again. So if you come here, you'll see that we don't have the risk column, right? We don't have the risk column. That's what we need to use to determine these other values. So what we're going to do right now is that we're going to create that risk column. And how do we do that? So we're going to create a function that is going to classify several risks, right? We're going to have something like high risk, low risk, and probably medium risk. Okay, so what we can do now is I'm going to just create a function here. So I'm going to call this calculate risk. Okay, so inside of this function, I'm going to pass 3 parameters, right? So what are going to be the criteria for us to create our risk, right? To determine the risk. So we can say somebody is going to be of high risk if they're infected, right? Based on this criteria that we mapped out here, and they have probably a high leg swelling score, and they have their income status is low. Okay, so I'm just going to write it down here, as a comment. So you have high risk if your income is equal to low, and you have the high, I'm going to say your leg swelling is greater than or equal to 50, and also which other we can see also, and you don't have latrine, your latrine access is equals to, in short, we can say here, and you are infected, that's infected is equals to 1 already. From here we can see that. And then another one we can actually say is that you have a low risk. You have a low risk if probably you don't have your latrine I'm going to call that medium risk. Medium risk if your latrine access is equals to probably, that means it is absent. Okay, and also if there is any other case, you have a what? Low risk. Exactly. Now, so what we're going to actually do in this function is that we're going to actually pass in how many parameters? We'll pass in 3 parameters. We're going to pass 1, 2, 3, and 4. Sorry, 4 parameters. So we're going to call this income. So we're also going to pass in leg swelling. Another parameter is going to pass in is infected. I'm also going to pass in latrine. I'm just going to call it latrine. I think that works perfect. That's okay. Okay. So I'm going to leave the colon here. All right. So what we are saying based on these particular conditions that we've put in here is that if, now we're going to say that if your income, now remember we're going to actually trace this to this so that if the income is greater than, right? So probably we can actually check out that. So if the income is greater than, we said if income is, because how did we classify income? Classify the income as high and low. So if the income is equal to low, right? And then the next thing we said the leg swelling is greater than or equal to 50, and infected is equal to 1, right? Now what we're going to do right now is we have to return high risk. So once we've got that return high risk, so we're going to say else if latrine is equal to absent, then it should return medium risk. Okay, and the last one is else return low risk. All right, so now remember that's what we're trying to do. So we're trying to basically predict, we want to predict the risk of lymphatic filariasis. Okay, so the data that we've got. So the next thing we're going to do right now is that we're going to create our risk column. So I'm going to actually say ntd df. So I'm going to say df risk level. So it's now equals to df dot apply. So we're going to use the apply method, and then we're going to call the lambda. There's a function called the lambda. Is a function that's usually called once. So we'll call the row, and I'm going to actually call that function calculated risk, and then I'm going to pass in inside of this calculated risk. I'll pass in the row. So this is going to be the row now. So for income, so we've got income status. So I'm going to pass that income status. And then the next argument is going to be for leg swelling. So I'm going to actually get that from here. So you can actually see that. Okay, so I'm just going to, just to make this code readable. So I'm going to put row. Okay, so row, I'm just going to put the next one. So we've got infected. And the last one is going to be for a row of, that's going to be latrine. So that's latrine access. So say latrine access. Okay, so that's fine. That works. So the last thing we're going to do right now is outside of this. So we'll say axis is going to be equals to 1, because so basically that's it for our function. And then the next thing we're going to do right now is so we're going to actually now encode our values, right? So we're going to actually encode them. So what we mean by encoding now is that in machine learning, it's very imperative for us to understand that machine learning works with numbers, just like I mentioned before. So right now that we've created our risk level, if we actually print df, okay, you see that we now have our risk level. So the next one we're going to actually do now is the encoding. And now for us to do the encoding, basically we are going to now convert all the categorical variables into numbers, such like sex, latrine, access, income, and also risk level. So basically what we're going to do right now is that we're going to say df, then we're going to say sex, df sex, encoded. So it's equals to df sex. So we use the map method dot map, then we enter a dictionary inside of it. So then that's going to be for male, it's going to be 0, and then for female, it's going to be 1. Okay, so that is that for sex encoded. Now for latrine encoded, so we're going to actually do df latrine encoded. Okay, so it's going to be equal to df, then we've got latrine access. Okay, and we're going to do dot map, so use the dot map method, and then we'll now have for male, for latrine now, it's going to be for present, it's going to be 0, and for absent is going to be 1. Now the next one we're going to do now is we're going to do for df dot income encoded, and that's going to be df income status. So we're going to actually do dot map, so call it dot map method, then pass our dictionary inside of it, and we're going to have for high, it's going to be 0, for medium, it's going to be 1, and for low, it's going to be 2. So now we just need to cross check this from where we declared our variables here. You'll see that we clearly said it that for income we've got high, medium, and low, and present, absent for latrine access, male, female for sex. Now because we've created a new data frame column which we call our risk, so we're going to have our df, so we'll call this our risk encoded, and this is going to be our target variable. So we're going to call this df, so we get back there, so this is our risk level dot map. Okay, so inside the method, so pass a dictionary, so inside of that, so we're going to grab for low risk is going to be 0, and for high risk. Okay, so I'm just going to arrange it. Well, let me put the medium risk, so that's going to take 1, while the high risk is going to take, it's going to take 2. I think that works, so we cross check that, okay, to be sure. So I'm just going to run it to be sure everything is okay. So to run it, I used shift enter. Now the next thing we're going to do now is this is where we're going to perform our machine learning, right? And since we already have our data frame, we've got some parameters, so it will be very important for us to know what our x and y values are. That's what we popularly use in machine learning. And I can actually do df, so let's inspect our data sheet. So you can see that here all of these are now from sex, latrine, income are now represented in numbers, okay, in integers rather. Now we've got some steps that we're going to take. First of all, we're going to actually declare some of our features. We'll do something called feature engineering. Yeah, we'll talk about what our x is. So for our x is going to be equal to for df. Now, because we're passing more than that, so we'll have an encrypted list. So we'll have inside here, we'll have our age. We'll have our, I'm going to use sex encoded. So this is going to be our features. Then we've got leg swelling score. If I spell that correctly, then the next thing we're going to have is our latrine encoded. Then we'll have our income encoded. Then we'll have our infected. Now, essentially, what we are doing here now is we're trying to predict the risk the risk of developing lymphatic filariasis. So what it means is that our y is going to be df in our data frame is going to be risk encoded. Okay, so I'm going to run that to be sure nothing goes wrong. So I can just print x. Okay, that works fine. Print y. That works very well. Okay, just to be sure that we are on the right path. Now, in order not to waste so much time, I'm going to go straight into talking about the next line of action. Is going to be to train. So first of all, we're going to split our data. So we'll do what we call splitting. Then after splitting it, we're going to do what we call training our model. Then after we're done training our model, we'll make a prediction. Then after making a prediction, then we'll now determine the accuracy of our prediction, and then we'll save our model. So just bear this in mind, these are actually the machine learning procedures. Now the next thing we're going to do right now is to split our model. And now to split our model, what we're going to do now is we're going to divide this to x train, x test, y train, y test. Now equals to, we're going to call that method. So we're going to call the train test split method. So we'll pass our x, our y inside of it, and also a random state is going to be 3 or whichever number, and then we can actually have our test size to be 0.3, 0.3 or 0.2. Now what this means is that I'm going to divide this data set into two parts. Now 70%, which is 0.7, that's 70% is going to be used for training the model, and then 30% is going to be used for testing the model. Now I'm just going to shift enter, nothing happens, everything is running perfectly fine. And then the next thing I'm going to do right now is to train the model. Now to train the model, I'm going to this model is going to be equal to, I'm going to call this object, and I'm going to pass the maximum iteration as 1000. So what this means is that it's going to actually train the model with the validity that's going to iterate for 1000 times to get the very best fit. Now, because I've actually initiated this this object, so I'm going to actually say model.train, model.fit, rather I'm going to use fit, so I'm going to pass in x train, y train, okay? And that's it. So to check if we shift enter, and yeah, everything is running very perfectly, and these are actually some of the parameters. Now, the next thing we're going to actually do now is now to run our prediction. And now remember, like I explained here, now this data set is divided into two. We've got the training data set, which is the 70% of the training data set. This is the 30% of the testing features. This is the 70% of the training features. This is the 30% of the testing features. Remember that we divided our data set into two. For the x, this is what we call this x here. We call them the features. We call it the features. And this is what we call our targets. Okay. So essentially what this means now is that the 30% that we've got here from this training, from this data that model that we've trained now, will now make a prediction, right? So we're going to actually make a prediction now with our 30% of our test. So to do that, we can actually say, we can do model, we call the method predict. Okay, so that's going to be x test. Now when we run this now, it's going to actually return an array, and that array is something that is more like an array that we can now use to compare with the 30% of the testing that we haven't touched to know our accuracy. So if I just run that, so this is just the array, okay, of the risk. Now what we can now do right now is that instead of running that, we can actually save it as a variable. We can call it prediction spreads is equals to this, and yeah, of course that works. In order for us to make the prediction, we can now say accuracy for model is now equals to, we call the accuracy, we call the method, and we pass in our spreads and y test. So essentially we want to just know between what we've now predicted with our x test, we want to now compare that array with that of the y test that we already splitted out. Okay, so actually you can also print accuracy of our length model. Okay, so we can actually now call accuracy and we'll print that the accuracy of our model is 1.0. So that means it's very, very accurate. Now remember that sometimes it's always very important for you to get that the larger the sample, the much more better. So yeah, we can actually use decision tree to check out this also. But one of the things we need to understand is that this is there are several models out of there. So from there, it looks like our model is very perfect. And to save our model, so actually going to say with open. So actually just going to give the name of the file. It's going to be, I'm just going to call it lymphntd.pico. Then actually say comma, we'll say wb as file. So pico dot dump. We call the dump method, and we pass in model and then file. So that works fine, and we run it, and that's it. So to check our model, you can actually click here, and this is it. So I'm going to click on that, say open anyway as text editor, and this is our model. So guys, thank you very much for this session. All of this code is going to be dropped on my Git, and definitely we're going to be working on other models, and this is just the beginner series. The next part will be moving into decision tree classifiers and also some other pre-processing models for images and all of that. So thank you for your time for this particular session, and have a nice time. Bye bye.